Okay student, in the previous video we have discussed the three conditions that when the displacement time graph is parallel to time axis, and when the displacement time graph is a straight line, and the third one is when the displacement time graph is just parallel to displacement axis. These three conditions we have just discussed in the previous video. Now in this video we are continuing the next one, that is when the displacement time graph is just a curve line. Okay, this is a curve line and displacement time graph is a curve line. Then how we will able to find out the velocity? How we will able to find out the velocity? In this case we will first draw a tangent to this curve. Okay, this is a curve which is showing non-uniform or a variable velocity. So in order to find out the velocity at this point, we will first of all draw a tangent. Okay, and considering this tangent, we are just finding out the velocity, instantaneous velocity at a particular point by drawing a tangent. Okay, and by drawing the tangent line with just having slope, okay, just drawing a perpendicular on the x-axis in respectively the final position of the y-axis, we will able to find out the slope of this line, this tangent line, okay, of the curve. Okay, so in this case when the displacement time graph is a curve line, we will able to find out the instantaneous velocity at that particular point. If someone asks you to find out the velocity of a non-uniform just a graph of displacement time graph, then at that position, in that position we will consider a tangent which we will draw on the curve line, and at some particular point, at some instant, we will able to find out the instantaneous velocity. Okay, by just plotting the graph, plotting the slope. Okay, so in this case the slope of the graph will be what? Suppose this is A, this is B. Suppose this at this point this is A. Suppose this is how we will able to find out? Just clear it, this label, we will draw it. Okay, suppose this is C, this is B, this is D, and suppose this is C. So with taking the concern of this point, okay, this point, suppose some diagram has not cleared, but you have to understand this here. So how we will able to find out the slope of this line? We will consider BC upon CD, means del x upon del x delta x divided by delta time. So BC will be what? 8 minus 2, and what about the DC will be 3 minus 1. So in this case we will able to find out the instantaneous velocity at some particular point. So we will able to find out the velocity at point A. So velocity, we can consider here velocity at A will be equal to just what will it will BC upon what, or we can write delta x or upon CD, y-axis upon x-axis. So it will be 8 minus 2 upon 3 minus 1. It will be what? It will be 6 by 2. This is meter, this is second. So yeah, I am writing here only. It will be 3 meter per second. This will be the answer. This is the instantaneous velocity, and which gives a velocity at some particular point A. So all these graphs, what we are getting at the final position? We are getting that number one position, that when the displacement time graph is parallel to time axis, the body is stationary. And what will happen when the body is moving with just a straight line? When the displacement time graph is a straight line, we have discussed earlier in the earlier video. So in that case what we will get? We will get uniform velocity. Third In the third graph, we have studied that what will happen when the displacement time graph is parallel to displacement axis. We have discussed, which is quite impossible. So this case is impossible. And what will happen when the displacement time graph is not a straight line, not parallel to any axis, it is a curved line. In this case, what will happen? In this case, at some particular point, we will find the instantaneous velocity. So it means what? It means the body is moving with variable velocity, okay, non-uniform velocity, and has some acceleration. So we can write here it is moving with non-uniform velocity when the displacement time graph is a curved line. In this particular case, the body is moving with non-uniform velocity. Non-uniform velocity, we can say that with some acceleration will be there, with some acceleration. Okay student, up to this level just go through. We will just meet in the next video. If you like this video, then subscribe the channel also. Thank you.